And after doing this, one of the most kind of tricky operation is the removal or deletion of this a certain node from these tree structures. Okay, first thing you have to do is that you need to find the node to delete through the recursions, right? Through the searches, you have to find out that node. So in the binary search tree, deletions are three cases. First case is deleting a node with no children. For instance, this is the case 1. We want to remove the 0, and then through the search operation that we just discussed, we go through this chain and we find 0 here. And then what we can do is that this 0 can actually navigate to the parent node and set the parent node, set to's LHS equals empty node. That's how you can handle this removal. And then after setting to's left hand side empty, there is no further going to here, right? Because it's now broken. And then 0 is just same as it's being deleted, right? That's actually pretty easy. And then another case is that deleting a node with one child, right? For example, we want to remove 2, right? And how to do that? Actually, that's the case. How to do this? We want to remove 2. And then the thing that you can do is that to's set to's parent left hand side is equal to the to's child, right? 2 will have only one child, because it's the case of a node with one child case, and 2's child is only 1, so we means that we can just remove it, and 3's left hand side is now pointing at 0, right? It's simple as that. So means that we are just replacing this middle node with the child node, the grandchild nodes of that parent, right? So that's this case. And then the third case is actually much kind of delicate situations. For example, let's imagine that we are trying to remove a children with 2 node with 2 children, like 5. Let's imagine that we want remove 5, and how to do that? Actually, that's kind of tricky question, right? How to do this? Why don't you pause for a second and can you guess any idea? Can we just move 4 up? Can we just move 7 up? Eventually, what we are going to do in this example is that, but there is much more sense here. Why don't you pause, hold for a second, and think about yourself. Alright, so deleting a node with 2 children is either of this case. You can solve this. A maximum in the left hand side, maximum in the maximum value of the left hand side, or a minimum value in the right hand side. We find that minimum value of the right hand side. And then substitute the node to delete the found value. Substitute the node with the delete with the found value. So we just swap it, right? And then we just, for example, if we want to swap with the minimum of the right hand side, which is 7 here, and we swap the value, like this, 7 and 5. And then what we do next is that delete the found node in the left hand side, and then we delete the 5. So we create the structure like this. Or the other way around is this, which is in this way, right? What we do is that we just swap the maximum value of this left-hand side, which is 4, and we swap it 5 and 4, and then we just remove the 5, and then we have these tree structures. Let's find out in further detail in the next slides, right? So, for example, imagine that we have this is the original tree structures. At the bottom of it, this is the structure that we have at the moment. And we want to remove 3. And how to do that? How to remove 3? First idea is replacing it with the minimum of right hand side. And the other idea is substituting it with maximum of the left hand side, right? So how to find the minimum of the right hand side? First, we go to the right hand side and keep going left. Keep going left. Going left means that we are going to the lesser value until we hit empty. We keep going the left hand side. Means that eventually the last left hand side node is the minimum value. So we go to the first go to the right hand side, and to find out the minimum we keep going the left hand side. And the 4 is the value, which is the 4 here. The other idea is that go to the left-hand side and finding out the maximum value of the left-hand side. How to find the maximum value of the left-hand side is keep going the right-hand side, right? First we go to the left-hand side, and then after just right after that, we keep going the right-hand side, and we eventually hit the 2. Right? Because that it doesn't have any right-hand side node here, means that 2 is actually the last of the right-hand side. So we went to the left-hand side and we hit 2, and right after that we find out that we don't have any further right-hand side to go to, means that 2 is the last element. And then actually 2 is the maximum value of this left-hand side. Right? Okay. And after that, what you wanna do is that we put 4 here, we put 2 here instead of 3, and then after that, we want to delete the 4 from the right hand side. By cutting here, we delete the 4 from the right hand side, or we remove the 2 in the left hand side, right? And then we remove 2 here. And then we have 0, right? And yeah, this is the long deletion code. At this moment, I'd like to recommend you stop the video and go to the MATLAB and start programming. We already have insertion, search, and deletion. Means that we have at least basic functionalities of these 3 structures, and you were given a whole lot of these codes, and then you must be able to type these. Okay, right. So before we go further, I'd like to give you a short annotation on this code, right? And this is that. Okay, so this is searching through operation, search operation, in short, search operation, in short, and then this is what? This is the case 2. Case 2. This case 2 means that if the empty, no, it's not empty. No, it's not empty. Means that both hands are full. Means that it's case 2. And then what you want to do is nodes get right hand side and find the minimum, and then node minimum, right? And we set the node minimum value as the current value and delete the node from the get right hand side of that minimum node nodes. Node with minimum value, right? So that's the case 2 operation. And then the next thing is this. We want to do is the case 1 and case 0, right? So this is the case 1. And the case 1 is the left hand side is 0. Left hand side is exists, and right hand side doesn't exist. If it exists, it's in case 2, it's already been dealt with. Means that if the left hand side is O, there is, then right hand side is not there. Because if there was, then it's case 2, but case 2 is already filtered out by the upper if statement, and this if statement means that it doesn't have the right hand side. Similarly, this is another case 1, but with the right hand side there is, and left hand side there isn't. So this is how we operate in the case 1. And then this is the last one is so this is the case 3, and this is case 2, and this is the case 1, right? So this is the right hand side, there isn't, left hand side, there isn't, right? So this is how the code is structured. And I'd like to ask you to stop the video and start coding, right? In the next slide said, I will just assume that you already implemented some of these codes. Right. After doing that, you must get some errors. Should implement the find min and find max. Actually, this is the find min and find max. So finding minimum in the binary search tree. Actually, I already showed you how to find the minimum in the binary search tree. To find the minimum, what you have to do is keep searching to the left-hand side. Keep searching to the left-hand side, and 0 is the smallest value here. Keep following the left-hand side, because you are going to the left-hand side, smaller value, left-hand side, smaller value, left-hand side, smaller value, and then the last left-hand side value is the smallest value. Finding maximum is the same thing. You have to go to the right hand side all the way down. And what it means that keep right hand side bigger value, right hand side bigger value, bigger value, bigger value, and then we can't go to the right hand side any further. It means that we already hit the maximum value, right? And this is quite simple. So find maximum is that keep going to the find the maximum value the recursive way. And find minimum is keep going to the left hand side is the find minimum value. And this find maximum and find minimum is required. Here is find minimum here. This is required. So you kind of get an error in the previous slide said, but if you add this find minimum function here, then you will be fine. Okay.